We move to Leandro.
Patrick.
Oh, Patrick.
Leandro's in the audience.
Okay.
I don't know how it sorts the speakers, but not correctly. Do you mind if I switch the display?
No, go ahead.
It's only a 50-50 chance, right? Cool. So, yeah, I'm Patrick, not Leandro, who is over there if you do want to speak to him. And, yeah, I'm going to be talking today about some work that we've been doing at STFC in expanding the Galaxy platforms to material science use cases, which, in this context, is going to be X-rays for catalysis. So, here's down. So just to give some context before we get into it. So I am based in the scientific computing department at STFC. And broadly speaking, we produce software which supports the activities at ISIS and Diamond, along with other activities at STFC. And some of the software that they'll be using, they'll develop in-house, and some will be developed by us in the department. And one of those services which we provide is Galaxy. And in this piece of work, we've been using it for an application involving X-ray absorption spectroscopy for users of the Catalysis Hub. So the Catalysis Hub is also based at the Harwell site and essentially acts as a kind of intermediary between researchers in catalysis and Diamond, where they can apply for a block of beam time as a group. And it is a user, a member of the Catalysis Hub who approached us about this potential use case that we're going to kind of talk about today. So essentially, he came to us, was saying, there are these papers that people are producing in catalysis science, and sometimes you will get a data object as a kind of supplementary piece of information, along with the information that's contained in your actual paper itself. But this kind of isn't the full picture. So you might get kind of your final plots and kind of description of your methodology. You might get the kind of raw, or possibly kind of that first step of analysis where you normalize your data in this data object that's distributed and minted with a DOI, and kind of, okay, we'll say that it's findable, we'll say that it's accessible. But if you kind of look a bit further down that fair tree that I'm sure you're seeing for the 10th or 11th time today, it maybe doesn't hold up as much when you start looking at interoperability and reusability. So kind of we've not got these sort of parameters that are used for analysis. We've not got details about the versions of the software that you've used, or which outputs came from which files. And so that makes this kind of interoperability and reusability more difficult. You've not got those connections to applications and workflows, and speaking from experience as a novice in this area of science, it's really hard to actually get the graphs that you see in the paper if all you're given is the kind of raw inputs and the software that was possibly used, possibly a different version. It's hard to know where to go. So the ultimate aim here was, okay, we want some platform or some service whereby you do your analysis with it, and all of this stuff kind of happens without you having to worry about it. And so in our department, in our group, we did have some experience with Galaxy, which you will have seen the logo again in some of the previous talks on workflows. But essentially, Galaxy is an open source web-based platform targeted for fair analysis of data. You define tools, which you kind of might think of as nodes, if that's your preferred terminology, that get combined into workflows. It supports interactive environments like Jupyter. And then probably the kind of, I think you're looking at some of the other stuff that's been talked about, one of the key features is the ability to kind of manage and share your results and workflows between users. So it's a kind of user-facing platform, and that's kind of one of the key strengths. And ultimately, the end goal is to get the reproducibility, which is what we were interested in, which is why we thought it might be a useful tool for this use case. And then another really key aspect is the community for Galaxy. So Galaxy doesn't have a kind of community in X-ray or neutron or muon science until recently. It originated in bioinformatics, and that was sort of 19 years ago, and it's pretty big. We mainly interact with the kind of EU Galaxy community, but there's also community sort of in America and Australia. And the fact that there is this really large community whose impressive statistics are probably 3 orders of magnitude above what we're getting at SDFC means that you kind of really benefit from a lot of work that they're doing without you having to do it. So things like the training platform, that Galaxy Training Network, is really useful. It's a really good platform for both learning about how to do your analysis in a kind of particular scientific domain, but also how to just use the Galaxy platform in general, and also how to deploy the Galaxy platform and administrate it as a kind of Galaxy server admin. In addition, there's this kind of training infrastructure as a service. So even if you don't have the capacity to run training, the Galaxy project will help you with that. And overall, it's just nice to be able to benefit from the work of others. In terms of what we do, then, kind of as a sort of new Galaxy community, the primary thing and the one that I'm going to focus on the most today is develop tools, right? So I said this is kind of bioinformatics. There were no X-ray tools day one, so that's what you have to do if you're kind of thinking of adopting this for a new use case. And in our case, we are running a small instance of Galaxy, but you don't strictly have to. If you kind of reach out to the Galaxy community, they're supportive, and you can kind of get your tools published on some of this sort of at usegalaxy.eu, and kind of it will use this existing infrastructure. So the barrier to entry is as high as you want it to be, really. And support from the European Galaxy community has been really good and essential for our journey with it. So to get into some specifics then, so I mentioned that our use case that we were doing was X-ray absorption spectroscopy. So we were kind of shown this overall workflow in reality using Demeter, which is a package written in Perl, and then there is Larch, which has also been mentioned at various points, which is the Python implementation, basically offering the same functionality, but with better prospects for long-term support. So that's what we'll go with. And you're given this kind of overall workflow, and then you have to kind of ask yourself, where do you create the tools for Galaxy? So the key things to consider are a Galaxy tool takes files as inputs and gives files as outputs. So anything that you want as a kind of intermediary file should happen at the end of your tool. And then also the level of interactivity that you need is important. So if you kind of want to alter a process, those parameters go into the Galaxy tool, and then you kind of can't change it until it's finished running. So you might add, in this case, sort of more boundaries between areas where you want to say, well, actually, I want this path file as a kind of intermediary output, and I want to be able to interact with my path selection independently, even though in the original workflow, it was all one step or one tool with lots of little steps, depending on your perspective. So in terms of the Galaxy UI, I've kind of been mentioning tools. So what does that really mean? This is what you would see as a user. So the middle section is essentially your tool input. As a Galaxy tool developer, you go through, you find the relevant parameters for this stage in the analysis, and this kind of form-based input is all built with XML. The schema is really well defined by the Galaxy community, and there's a VS Code extension to help you write it, which is good because I wouldn't remember all the options otherwise. And this is how you build your input. And then the other kind of important high-level points are how you define your dependencies and how you define your command. So your kind of command is run within a container and is templated out with these sorts of things here. So merge inputs .format.is zipped is potentially one parameter of your form, and Galaxy runs all of this in containers. So if you have a container already, that's great. You can just say that's your one dependency or your one requirement, sorry. Or if your packages are on Conda, then you can specify these, and there are CI pipelines to build hash all of that into a horrible string that you can't remember and publish it for you. And then that will be the container that your stuff runs in, and it runs reproducibly because you've built it once and then reuse it every time you run the tool. So if that's a tool, then how do you get your workflow? So there's kind of two options here. Either you can build all this by hand, ahead of time with sort of drag and drop functionality, I'm sure similar to any other workflow UI. Alternatively, if you kind of run things one by one, so in that previous screen you saw the kind of the form-based UI, you can run that, get an output, run another process on it, and keep going, and then say, okay, that's all the stuff I did. I want to turn that into a workflow, and you then click extract workflow, and you would get, I mean, you won't get it laid out like this because I laid this out by hand, but you would get a workflow built automatically from things you have done. And so way back at the start, I kind of justified all this by saying, well, look, we want to capture all this information. And this is kind of, what it looks like in the UI. And if we want to reproduce or reuse this, is a kind of 3-click process. I can't say it's 1 click to redo something, but you would click on an output, it would expand, you would click on the rerun button, and it would repopulate the UI with everything that you did when you ran it in the first time, and then you click run again. So rerunning something is kind of that simple. All of your parameters are captured, what your input was, what your output was, the standard out of the process. And all of that goes into the kind of export formats for Galaxy. So common workflow language was mentioned earlier, which Galaxy supports, but really the kind of the sort of more complete options would be to export it as an RO crate, a research object crate. And that applies to both the history, which is to say the kind of list of your inputs and outputs and the connections between them, and also the workflow that you either created ahead of time or extracted. That they can both go into that RO crate, and you can publish that on some site to achieve something that can then be reused by others, which was what we wanted in the first place. So I've kind of approached this from the perspective of kind of what is the work that you have to do to bring Galaxy to a new use case, but there is other work. It's not that simple. We host an instance of Galaxy, as I mentioned, much smaller than the kind of main Galaxy instances. But you don't have to. You can rely on those. Development of training material is really important. The Galaxy Training Network is great, and I kind of think you would be foolish not to use it. But you don't have to, right? The development of software and the kind of understanding of the use case, depends to a certain extent. In this case, we don't develop Larch. But there are other use cases that we use Galaxy for where we do develop the underlying tools, and you might have to fix your own bugs or hope that someone else fixes them. The one thing that's kind of not optional is building a new community, right? There won't be any users of your new Galaxy tools for your new use case unless you go out and you put the effort in, you speak about where the value add is. But that's hard, so I've not talked about it today. Things that we haven't done, but we probably will want to do in the future. So I mentioned interactive tools once and then didn't mention them again, but essentially the simplest example you can think of is, instead of running a tool that completes and gives you an output file, you run a tool that then continues to run, such as a Jupyter Hub or Jupyter Server, and you can then run a Python notebook in time, and then when you're finished, the job ends, and you've got your sort of interactivity while it's running. And Galaxy also supports kind of a lot of options in terms of data sources and authentication that we've not fully explored, but if you're running this from a kind of facilities perspective, you're going to have all these services existing and you'll want to plug those in, and you can. And so that's pretty much it. Obviously, Leandro's here, as was already mentioned. But yeah, I obviously like to thank the rest of the team developing it at SCD, our main collaborator at the Catalysis Hub as well for kind of bringing this to us in the first place. And then, yeah, kind of the support from the European Galaxy community we've had via the EOSC Euroscience Gateway project, and also funding from the ALC and PSDI in the UK has obviously been essential. Some links that might be useful are there. And yeah, finally, thanks to everyone in the room for listening.
Thanks, Peter. Questions?
Okay, thank you very much. I'm quite interested in the XML to web form converter.
Sure.
Is it available as standalone tool? And could you please a little bit elaborate on that?
Yeah, so this is kind of so are you asking if you can generate the UI without needing to run the rest of Galaxy? So I'm not sure. I kind of would hesitate to say yes. The Galaxy server source code is quite monolithic. And as a kind of tool developer, you can get away without really needing to interact too much under the hood. Yeah, so I'm sorry. Yeah. So kind of as a tool developer, you write your XML, you might do some kind of light Python scripting. I think this on the second slide ultimately runs a Python script that we ship with the tool. But everything else is Galaxy server. So I doubt it, but I can look into it and try and find out for you.
Thanks for the talk. We're actually trying to do the same kind of things, but like each time I look at the Docker Galaxy documentation, I bounce back because I can see where to get started. So as someone who actually did get started and did something out of it, can you give me an advice on where I should go to get started?
Definitely the training. So Galaxy has a few sources of documentation. I don't know if you went to the training network or not.
No, I think I went on the documentation.
Yeah. So the read the docs is good for reference, especially for the kind of tool building stuff. It's got the schema there if you've not installed the VS Code installation. But the Galaxy, training.galaxyproject.org has the domain science tutorials, but it also has the Galaxy admin, server admin tutorials and the Galaxy developer tutorials. So both of those would be really useful. There's a kind of training pathway that goes from each one to the other. And actually, I got an email today that there is a kind of online Galaxy training session, I think in a couple of weeks' time, I think 7th of October. So I had no idea that was happening, but potentially look into that. You'll find that on the website as well.
And you said that you choose to run your own Galaxy instance, but this is not mandatory?
Yeah, no. So if you are interested, we can kind of put you in touch with the people who manage the main, like usegalaxy.eu. And so they were kind of, we were collaborating with them, and they have set up a materials.usegalaxy.eu that currently has our muon spectroscopy tools that I've not talked about, but we'll have our X-ray tools on as well. So that kind of removes that barrier of entry. You have less control. All you're doing is installing the tools. You can't, say, oh, actually, I want to change your authentication mechanism because it's not your site. But yeah, you don't necessarily have to. You probably will want to at least run something small for development, but not for production, I think.
Thanks a lot. We move on, otherwise we'll be late.